Now, when we're finding arc length, there are two, just like circumference, there are two kind of setups of the formula. There are also two for arc length. The first one I have written up here is using the idea of proportions. Okay, the idea of proportions follows that the arc length over the total circumference will be equal to the arc measure over 360 degrees. We also sometimes label arc measure as theta, and 2 pi r is circumference. So this is following a proportion because it's saying the part over the whole circumference is equal to the part over the whole 360. So proportionally, that works. The other way that we're going to see it, and this is a way that I tend to use a little more, is arc length. An equation to solve for arc length is the arc measure, again, which is theta, over 360 times the entire circumference. So what you're looking at here is the portion of the circle times the total circumference gives you that arc length. So there's two ways to kind of visualize what this formula is. Let's see our first example. So I've got a radius of 8 and a arc measure, which I label as theta sometimes, is 60 degrees. So using that second equation I looked at, I know the arc length is equal to 60 degrees over 360 times the total. So this is the portion of the circle I'm looking at, but I only want the length of this arc here. So the total circumference is going to be 2 pi times the radius, which is 8. Now I've got everything on the right side of the equation, so again I can just take out my calculator and plug that in. I'll type it as 60 divided by 360 times 2 times pi times 8. You can throw it all in together there. If you're unsure on when to put parentheses around, you can always do parentheses around more often than not. It doesn't hurt, so you can write it like that. It'll get you the same thing though, because I'm only dividing by 360. That total arc length is 8.378 units long. That's your first problem. In these next two examples, we're going to use that same formula. The arc length is the arc measure over 360 times the circumference, but different parts are given, and I want to find different parts. So in this first example, I want to find the circumference given these pieces of information here. So I see 40 degrees. Whenever you see degrees, you should think about arc measure. So that's our theta. So theta is 40. And then this 4.19 is right there on the curved portion, and that is our arc length. So that is 4.19. So let's plug in what I have, and let's see what I can solve for. 4.19, again I said, is the arc length, equals 40 degrees over 360. Times, now I could write 2 pi r, but remember from how we derived this formula, 2 pi r is circumference. So I'm just going to write it as C. Keep in mind, you could plug in 2 pi r and solve for the radius, but I know I want circumference, so I'm just going to skip a step. Now, to solve this one out, I want to get circumference by itself. To do that, I want to get rid of the fraction there. So, let me get a different color. To get rid of the fraction, I want to multiply by its reciprocal, which means multiply by 360 over 40 on the right side of the equation, because that will cancel the 360 and the 40. I have to also do it on the left side. So times 360 divided by 40. Kind of running out of space, but that's okay. When I do that, I'm going to do 4.19 times 360 divided by 40. I get 37.71. So the circumference of this circle is 37.71 inches. Great. Okay, next problem. I am looking at a figure that is a given radius. So this time I know radius, it looks like that's 15.28. Great. And again, I'm given my arc length, looks like 44 meters. So let's plug things in. 44 meters equals, I'm actually going to take the meter out so I don't confuse myself with units while I'm doing my math. So 44 equals, I'm looking for the measure of arc RS, and that is theta. So I'm going to leave that as the variable theta over 360 times 2 pi r. So 2 times pi times the radius of 15.28. Okay. Now there are a lot of ways that I can continue solving this problem out, but the one thing that I see that I usually want to do is get rid of fractions if I can. Here the denominator is 360 degrees, so what I'm actually going to do is I'm going to multiply both sides of the equation by 360. So multiply by 360 here and here. Just like I did over here to get rid of the fraction, I'm going to do a similar idea on this side. So when that cancels that 360 out, on the right side of the equation, I'd be left with just theta times 2 pi 15.28. On the left side, it's going to be 44 times 360, a big number, but that's okay. 15,840, and you might get concerned, say it's too big. No, that's fine. We can work with that. Now, remember, I want to solve for theta, so I want to get all of the other stuff here out of there. So I'm going to divide the whole side by 2 times pi 15.28. And remember to do that in parentheses on the other side. 2 pi times 15.28. Watch how I do it here. So take that whole number, 15,840, divide it by, in parentheses, that whole thing. So final answer, theta is 164.98. That 7 there is going to bump up to an 8 degrees because we're talking about an arc measure. And that is using our arc length formula.